When a body, say this is the level of liquid, when a body is partially immersed or fully immersed in this liquid, there is an upward force, which acts on it. This is the force due to the liquid which is resisting this external object. This is the buoyant force, or you can call it as buoyancy. So this buoyant force is acting against where? Because if this is an object, the gravity is in this direction, but this is acting against it. So the buoyant force is acting at the center of the gravity of the liquid. If this is the object, so there is a center of gravity of that object. So the buoyant force acts at the center, the center of the gravity of the liquid, which is displaced by the immersed part of the body. Okay, so say, and this point is called the center of buoyancy. What I'm trying to say here is that the liquid which is displaced by this, say some, previously it was this much of liquid, we immersed it, so there is an increase in the liquid column. So this buoyant force which is acting here acts on the center of gravity of the liquid which is being displaced by the immersed part of the body, and this point is known as the center buoyancy. Archimedes principle. When a body is partially or fully immersed in a liquid, as you see here, it loses some of its weight, and it is equal to the weight of the liquid which is displaced by the immersed part of the body. If this is the liquid level and there is a immersed fully or partially, then this body is going to lose some weight, and this is equal to what? This is equal to the weight of the liquid displaced by the immersed part of the body. So this much of liquid which is being, this much of bedding which is the weight is immersed, so this much of this amount of liquid is also being displaced, and Archimedes principle exactly say that. So if T is the observed weight of body of density, say sigma, when it is fully immersed, so it is inside here, so if this T is observed weight of the body of density, say sigma, when it is fully immersed in a liquid of density, say this liquid has density this rho, the real weight would be W equal to T divided by 1 minus P by rho. P minus sigma, sorry, this is sigma. T by 1 minus P by sigma. P and sigma. P is the, as we said, that this sigma is the weight of the, we are talking about the body, so it's a density of the body. This is the density of the body, and this is the density of the liquid in which it is immersed, and T is of course the observed weight. So the real weight would be of this relationship.